Assalamualaikum. My name is Muhammad Iman Hakim bin Muhammad ZAMBRI. Today I will present my topic Relations and Function, their application in computer science. In this presentation, I will explain what relations and functions are, why every function is considered a special case of a relation, and how these concepts are applied in computer science. First, let's understand what a relation is. In discrete mathematics, a relation is a set of ordered pairs that connects elements from one set called the domain to another set called the codomain. Mathematically, a relation is a subset of the Cartesian product A times B. A function is a special kind of relation. The difference is that every element in the domain must have exactly one corresponding output in the codomain. Because of this rule, every function is a relation, but not every relation can be called a function. This table shows the differences between a relation and a function. A relation is simply any subset of A times B. So, one input can be connected to multiple outputs. However, a function has stricter rules. Every input can only be connected to one output. Therefore, every function is always a relation, but some relations are not a function. Now, let's look at an example. The domain consists of the numbers 1, 2, 3, and 4, while the codomain contains 2, 4, 6, and 8. The relation R consists of the ordered pairs 1, 2, 2, 4, 3, 6, and 4, 8. Looking at the mapping diagram, we can see that each element in the domain has exactly one arrow pointing to one element in the codomain. Since every input has only one output, this relation satisfies the definition of a function. Next is the calculation process. We are given the function f(x) equals to 2x. We substitute each value of x into the function. When x equals to 1, the output is 2. When x equals to 2, the output is 4. When x equals to 3, the output is 6. And finally, when x equals to 4, the output is 8. The resulting ordered pairs are exactly the same as the relation shown earlier. Since each input produces one output, this confirms that the relation is indeed a function. Now, I would like to explain one important application of functions in computer science, which is database systems. In database, information is stored in tables using rows and columns. Each record easily has a unique identifier called a primary key, such as a student ID, employee ID, or customer ID. In this example, each student ID is linked to exactly one student names. For instance, student ID S001 belongs only to Ali. S002 belongs only to Aisha, while S003 belongs only to Abu. This relationship is considered a function because every input, which is the student ID, has exactly one corresponding output, which is the student name. No student ID should be linked to two different students at the same time. If that happens, the data will become inconsistent and could cause errors when retrieving information. This concept is very important in database design because it helps maintain data accuracy, consistency, and integrity. By assigning a unique student ID to each student, the system can quickly search, update, or delete records without confusion. We can see this in many real-life systems. Universities use student ID to access academic records, attendance, and examination results. Banks use account number to identify customer financial information, while hospitals use patient identification numbers to retrieve medical records accurately. Therefore, the mathematical concept of a function is not only used in theory, but also plays an important role in designing reliable and efficient database systems that we use every day. In conclusion, relations describe how elements from two sets are connected. Functions are special relations because every input has exactly one output. This unique property makes functions reliable and useful in many areas of computer science, including database, programming, artificial intelligence, and algorithms. That's all from me. Thank you.